Continuing in section 1.2, next let's talk about how to determine if you have a function using what's called the vertical line test. It says here, if any vertical line intersects a graph in more than one point, the graph does not define y as a function of x. So let's say that this was your graph. This green line here. If you could take vertical lines and draw vertical lines through your green line, and each of those vertical lines only intersect your line in one location, not more than one, then the graph is a function. So we're going to say, yes, this is a function. So if this was your graph, when I draw vertical lines through this, I will see that the vertical line crosses in more than one spot. So this would be not a function. If this was my graph, when I draw vertical lines, here it would be fine, but it has to pass the vertical line test in all locations. So you'll notice here it crosses in 3 spots. So it would be not a function. So take a look at the next page and decide whether you think these two, they have the graph is drawn in black, and they have taken a vertical line in blue, and they're asking you, identify the graph in which y is a function of x. So pause the video and then decide which you would say. So this one on the left would not be a function because this vertical line crosses in 2 locations. This one on the right, no matter where I draw a vertical line here in this parabola, it crosses in 1 spot. So yes, it would be a function. Moving on to the next page, it says to analyze the graph of this function. And it says use the graph to find f at 5. So remember, what is inside the parenthesis is called our input. This is the independent value, the x value, the horizontal variable, and it wants us to find the function evaluated at 5. But we don't have an equation like we did last time. We have the graph. So let's take a look at this graph. The graph says, the title is called T-cell count and HIV infection. On the horizontal axis, this is the time after infection, and it's in years. So we've got the numbers from 1 to 11. And then on the left-hand side, we have the output axis, the vertical, and we have the average T-cell count per milliliter of blood. And we see the T-cell count goes down as time goes on. It looks like it goes down, can go back up, and then it kind of trends down. So an input of 5 would be right here. So we'd go up, I'd read the graph. Where does 5 cross the graph? Right here. And I'd read over to see what the output would be. So 400. So 400 T cells. Now, different this time here, because it says for what value of x. So this time you are looking for the input, but given the output. So this time you would take and you would look for the output of 100. Well, where's 100? Each of these grid marks are 200 apart, so 100 would be halfway. And so you would take 100 and you would go to where it crosses, it looks like right about here, and you would read down. So 9. So when x is equal to 9, the output is 100. So in the first one, we were looking for the output, but in the second one, we were looking for the input because we were given the output. So we were given the dependent value, the y value, or the vertical variable in this one. We can also take a look and be able to identify the domain and range from the graph's function, from the function's graph. So to find the domain of a function from its graph, you're going to look at all the possible inputs on the x-axis that correspond to points on the graph. And to find the range of a function from its graph, you're going to look at the outputs on the y-axis that correspond to points on the graph. So let's take a look at this with the next page. So here we have a graph of the function f here shown. So to identify the domain, it tells us to look at the x values. So the x values are, I'm looking at the x-axis is what I want to focus on, right? The x-axis. So look at the x-axis. And the line that they show me, this function f, is this blue line here. So if I look at the x-axis, I'm only going from, I have values from here to here. Nothing else. There's nothing past 1. There's nothing below -2. So I'm going to write this as the domain. I'm going to look at what x values are represented here. And those are the numbers between -2 and +1. Now, when you do these problems, it wants you to typically write your answer in interval notation. So what is interval notation? Well, interval notation is where I'm going to put the smaller value first. I will put the larger value second. So when you first see this, you might think this is an ordered pair. It's not. And then you're going to put either a parenthesis or a bracket, and you can have a mixture in the interval notation. You can have a parenthesis or bracket, one or the other on each side, depending if it is an open interval, meaning it doesn't touch that value, or if it's a closed interval, meaning it includes that value. So if I take a look here, let me erase this yellow. There's a closed dot here and a closed dot here, meaning the value of -2 is on the function and the value of +1 is on the function. So to write this in interval notation, I'm going to say the domain is between -2 and +1, smaller value to the left, larger value to the right, bracket on each endpoint because I am including those values. Now, to do the range, we said we're going to look at the y-axis. So the y-axis, which one is that? It's this right here. But I need to focus on what values are represented. So for the y-axis, I have values from here up to here. So where is that? That's 0 on the y and +3. So the range would be values between 0, remember I'm looking at the y-axis, and +3. So the range would be from 0 to 3, including both endpoints because of those solid dots. So this is the domain and range here. Now, you have a similar problem. So again, take a look at this, write out your answer, pause the video, write out what you think your domain and range would be, write your answer in interval notation, and then we're going to do it together. So our function f is right here. You should have got a domain of -2 to 1, open interval at -2 because there's an open circle here, closed interval at +1 because there's a closed circle here. The range, the y values go from -1 to 2, and this should be a parenthesis here and a bracket here, indicating this is including -1 and excluding +2. So how am I figuring this out? I am looking at the x-axis for the domain, and I'm just going to look at the x-axis, what values are represented from here to here. This is an open circle, so it doesn't include that. This is a closed circle, so it does include that side. And for the range, I look at the y-axis. So the y-axis goes from as low as here and goes all the way up to here. Those are the only points on this blue line. There are no values up here. There are no values down below. The -1 is a closed dot. The +2 has an open dot. So bracket, parenthesis. And then the last part of this section, 1.2, deals with identifying the intercepts. So you can have where it crosses the x-axis is called the x-intercept. And to determine that from the graph, you're going to look at the point where it does cross. And the same thing for the y-intercept, you would look at the y-axis. A function can have more than one x-intercept, but at most it can have only one y-intercept. So if we take a look here, we have x-intercepts and y-intercepts. So in the red, they highlight for you the x-intercepts. Notice you can have multiple x-intercepts, and it still is a function, or this would pass the vertical line test. But if I had multiple y-intercepts, then it wouldn't pass the vertical line test. So it wouldn't be a function. So the x-intercepts, to write those, we can write them as ordered pairs. And to be an ordered pair, it would be -3, 0. So -3, 0 on the y. X-intercepts will have 0 for y. Then we have -1, 0. And we have +2, 0. Now, when you go to write this in the MyLab math, you should always put parentheses around your ordered pairs and commas in between your ordered pairs. The y-intercept, it's in blue, so I'm going to write that one in blue. The y-intercept is where it crosses the y-axis. So here we would write 0, -6. Whenever you have a y-intercept, it has an x value at 0 because there's no horizontal movement. It's just a vertical movement to -6. And that is the x and y intercepts, reading them from a graph. That completes section 1.2, and you should move on and do the homework now in the MyLab math that corresponds to section 1.2.